1980 eruption of Mount St Helens. On March 27, 1980, a series of volcanic explosions and pyroclastic flows began at Mount St Helens in Skamania County, Washington, United States. A series of freatic blasts occurred from the summit and escalated until a major explosive eruption took place on May 18, 1980. The eruption, which had a volcanic explosivity index of 5, was the most significant to occur in the contiguous United States since the much smaller 1915 eruption of Lassen Peak in California. It has often been declared the most disastrous volcanic eruption in U.S. history. The eruption was preceded by a 2-month series of earthquakes and steam venting episodes caused by an injection of magma at shallow depth below the volcano that created a large bulge and a fracture system on the mountain's north slope. An earthquake at 8:32:11 PDT on Sunday, May 18, 1980 caused the entire weakened north face to slide away, creating the largest landslide in recorded history. This allowed the partly molten rock, rich in high-pressure gas and steam, to suddenly explode northward toward Spirit Lake in a hot mix of lava and pulverized older rock, overtaking the landslide. An eruption column rose 80,000 feet into the atmosphere and deposited ash in 11 U.S. states and 2 Canadian provinces. At the same time, snow, ice, and several entire glaciers on the volcano melted, forming a series of large lahars that reached as far as the Columbia River, nearly 50 miles to the southwest. Less severe outbursts continued into the next day, only to be followed by other large, but not as destructive, eruptions later that year. Thermal energy released during the eruption was equal to 26 megatons of TNT. Approximately 57 people were killed, including innkeeper and World War I veteran Harry R. Truman, photographers Reed Blackburn and Robert Landsberg, and geologist David A. Johnston. Hundreds of square miles were reduced to wasteland, causing over $1 billion in damage. Thousands of animals were killed, and Mount St. Helens was left with a crater on its north side. At the time of the eruption, the summit of the volcano was owned by the Burlington Northern Railroad, but afterward the land passed to the United States Forest Service. The area was later preserved in the Mount St. Helens National Volcanic Monument. Build up to the eruption. Mount St. Helens remained dormant from its last period of activity in the 1840s and 1850s until March 1980. Several small earthquakes, beginning on March 15, indicated that magma might have begun moving below the volcano. On March 20 at 3:45 p.m. Pacific Standard Time, a shallow magnitude 42 earthquake centered below the volcano's north flank signaled the volcano's return from 123 years of hibernation. A gradually building earthquake swarm saturated area seismographs and started to climax at about noon on March 25, reaching peak levels in the next 2 days, including an earthquake registering 51 on the Richter scale. A total of 174 shocks of magnitude 26 or greater were recorded during those 2 days. Shocks of magnitude 32 or greater occurred at a slightly increasing rate during April and May, with 5 earthquakes of magnitude 4 or above per day in early April, and 8 per day the week before May 18. Initially, there was no direct sign of eruption, but small earthquake-induced avalanches of snow and ice were reported from aerial observations. At 12:36 p.m. on March 27, freatic eruptions ejected and smashed rock from within the old summit crater, excavating a new crater 250 feet wide and sending an ash column about 7,000 feet into the air. By this date, a 16,000-foot-long eastward trending fracture system had also developed across the summit area. This was followed by more earthquake swarms and a series of steam explosions that sent ash 10,000 to 11,000 feet above their vent. Most of this ash fell between 3 and 12 miles from its vent, but some was carried 150 miles south to Bend, Oregon, or 285 miles east to Spokane, Washington. A second new crater and a blue flame were observed on March 29. The flame was visibly emitted from both craters and was probably created by burning gases. Static electricity generated from ash clouds rolling down the volcano sent out lightning bolts that were up to 2 miles long. 93 separate outbursts were reported on March 30, and increasingly strong harmonic tremors were first detected on April 1. Alarming geologists and prompting Governor Dixie Lee Ray to declare a state of emergency on April 3. Governor Ray issued an executive order on April 30 creating a red zone around the volcano. Anyone caught in this zone without a pass faced a $500 fine or 6 months in jail. This precluded many cabin owners from visiting their property. By April 7, the combined crater was 1,700 by 1,200 feet and 500 feet deep. USGS team determined in the last week of April that a 15-mile diameter section of St. Helens north face was displaced outward by at least 270 feet. For the rest of April and early May, this bulge grew by 5 to 6 feet per day, and by mid-May it extended more than 400 feet north. As the bulge moved northward, the summit area behind it progressively sank, forming a complex, down-dropped block called a graben. Geologists announced on April 30 that sliding of the bulge area was the greatest immediate danger, and that such a landslide might spark an eruption. These changes in the volcano's shape, this volume increase presumably corresponded to the volume of magma that pushed into the volcano and deformed its surface. Because the intruding magma remained below ground and was not directly visible, it was called a cryptodome, in contrast to a true lava dome exposed at the surface. On May 7, eruptions similar to those in March and April resumed, and over the next days the bulge approached its maximum size. All activity had been confined to the 350-year-old summit dome and did not involve any new magma. A total of about 10,000 earthquakes were recorded before the May 18 event, with most concentrated in a small zone less than 16 miles directly below the bulge. Visible eruptions ceased on May 16, reducing public interest and consequently the number of spectators in the area. Mounting public pressure then forced officials to allow 50 carloads of property owners to enter the danger zone on Saturday, May 17, to gather whatever property they could carry. Another trip was scheduled for 10 a.m. the next day, and because that was Sunday, more than 300 loggers who would normally be working in the area were not there. By the time of the climactic eruption, dacite magma intruding into the volcano had forced the north flank outward nearly 500 feet and heated the volcano's groundwater system, causing many steam-driven explosions, landslide, and climactic phase. As May 18 dawned, Mount St Helens activity did not show any change from the pattern of the preceding month. The rate of bulge movement, sulfur dioxide emission, and ground temperature readings did not reveal any changes indicating a catastrophic eruption. USGS volcanologist David A. Johnston was on duty at an observation post approximately 6 miles north of the volcano as of 6:00 am. Johnston's measurements did not indicate any unusual activity. At 8:32 am, a magnitude 51 earthquake centered directly below the north slope triggered that part of the volcano to slide approximately 7:20 seconds after the shock. The landslide, the largest in recorded history, traveled at 110 to 155 miles per hour and moved across Spirit Lake's west arm. Part of it hit a 1150-foot-high ridge about 6 miles north. Some of the slide spilled over the ridge, but most of it moved 13 miles down the North Fork Toutle River, filling its valley up to 600 feet deep with avalanche debris. An area of about 24 square miles was covered, and the total volume of the deposit was about 7 cubic miles. Scientists were able to reconstruct the motion of the landslide from a series of rapid photographs by Gary Rosenquist, who was camping 11 miles away from the blast. Rosenquist, his party, and his photographs survived because the blast was deflected by local topography 1 mile short of his location. Most of St. Helens' former north side became a rubble deposit 17 miles long, averaging 150 feet thick. The slide was thickest at 1 mile below Spirit Lake and thinnest at its western margin. The landslide temporarily displaced the waters of Spirit Lake to the ridge north of the lake in a giant wave approximately 600 feet high. This in turn created a 295-foot avalanche of debris consisting of the returning waters and thousands of uprooted trees and stumps. Some of these remained intact with roots, but most had been sheared off at the stump seconds earlier by the blast of superheated volcanic gas and ash that had immediately followed and overtook the initial landslide. The debris was transported along with the water as it returned to its basin, raising the surface level of Spirit Lake by about 200 ft. 4 decades after the eruption, floating log mats persist on Spirit Lake and nearby St. Helens Lake, changing position with the wind. The rest of the trees, especially those that were not completely detached from their roots, were turned upright by their own weight and became waterlogged. This provides insight into other sites with a similar fossil record. Pyroclastic flows. Initial lateral blast. The landslide exposed the dacite magma in St. Helens Neck to much lower pressure, causing the gas-charged, partially molten rock and high-pressure steam above it explode a few seconds after the landslide started. Explosions burst through the trailing part of the landslide, blasting rock debris northward. The resulting blast directed the pyroclastic flow laterally. It consisted of very hot volcanic gases, ash and pumice formed from new lava, as well as pulverized old rock, which hugged the ground. Initially moving at approximately 220 miles per hour, the blast quickly accelerated to around 670 mph, and it may have briefly passed the speed of sound. Pyroclastic flow material passed over the moving avalanche and spread outward, devastating a fan-shaped area 23 miles across by 19 miles long. In total, about 230 square miles of forest was knocked down, and extreme heat killed trees miles beyond the blow-down zone. At its vent, the lateral blast probably did not last longer than about 30 seconds, but the northward radiating and expanding blast cloud continued for about another minute. Superheated flow material flashed water in Spirit Lake and North Fork Toutle River to steam, creating a larger secondary explosion that was heard as far away as British Columbia, Montana, Idaho, and Northern California. Yet many areas closer to the eruption did not hear the blast. This so-called quiet zone extended radially a few tens of miles from the volcano and was created by the complex response of the eruption's sound waves to differences in temperature and air motion of the atmospheric layers and, to a lesser extent, local topography. Later studies indicated that 1/3 of the 45 cubic miles of material in the flow was new lava, and the rest was fragmented, older rock. Lateral blast result. The huge ensuing ash cloud sent skyward from St. Helens' northern foot was visible throughout the quiet zone. The near supersonic lateral blast, loaded with volcanic debris, caused devastation as far as 19 miles from the volcano. The area affected by the blast can be subdivided into three roughly concentric zones. Direct blast zone, the innermost zone, averaged about 8 miles in radius, an area in which virtually everything, natural or artificial, was obliterated or carried away. For this reason, this zone also has been called the tree removal zone. The flow of the material carried by the blast was not deflected by topographic features in this zone. The blast released energy equal to 24 megatons of TNT. Channelized blast zone, an intermediate zone, extended out to distances as far as 19 miles from the volcano, an area in which the flow flattened everything in its path and was channeled to some extent by topography. In this zone, the force and direction of the blast are strikingly demonstrated by the parallel alignment of toppled large trees, broken off at the base of the trunk, as if they were blades of grass mown by a scythe. This zone was also known as the tree down zone. Channeling and deflection of the blast caused strikingly varied local effects that still remained conspicuous after some decades. Where the blast struck open land directly, it scoured it, breaking trees off short and stripping vegetation and even topsoil, thereby delaying revegetation for many years. Where the blast was deflected so as to pass overhead by several meters, it left the topsoil and the seeds it contained, permitting faster revegetation with scrub and herbaceous plants and later with saplings. Trees in the path of such higher-level blasts were broken off wholesale at various heights, whereas nearby stands in more sheltered positions recovered comparatively rapidly without conspicuous long-term harm. Seared zone, also called the standing dead zone, the outermost fringe of the impacted area, a zone in which trees remained standing but were singed brown by the hot gases of the blast. By the time this pyroclastic flow hit its first human victims, it was still as hot as 680 deg F and filled with suffocating gas and flying debris. Most of the 57 people known to have died in that day's eruption succumbed to asphyxiation, while several died from burns. Lodge owner Harry R. Truman was buried under hundreds of feet of avalanche material. Volcanologist David A. Johnston was one of those killed, as was Reed Blackburn, a National Geographic photographer. Robert Landsberg, another photographer, was killed by the ash cloud. He was able to protect his film with his body, and the surviving photos provided geologists with valuable documentation of the historic eruption. Later flows. Subsequent outpourings of pyroclastic material from the breach left by the landslide consisted mainly of new magmatic debris rather than fragments of pre-existing volcanic rocks. The resulting deposits formed a fan-like pattern of overlapping sheets, tongues and lobes. At least 17 separate pyroclastic flows occurred during the May 18 eruption, and their aggregate volume was about 5 cubic miles. The flow deposits were still at about 570 to 790 deg F 2 weeks after they erupted. Secondary steam blast eruptions fed by this heat created pits on the northern margin of the pyroclastic flow deposits at the south shore of Spirit Lake and along the upper part of the North Fork Toutle River. These steam blast explosions continued sporadically for weeks or months after the emplacement of pyroclastic flows, and at least one occurred a year later, on May 16, 1981. Ash column. As the avalanche and initial pyroclastic flow were still advancing, a huge ash column grew to a height of 12 miles above the expanding crater in less than 10 minutes and spread tephra into the stratosphere for 10 straight hours. Near the volcano, the swirling ash particles in the atmosphere generated lightning, which in turn started many forest fires. During this time, parts of the mushroom-shaped ash cloud column collapsed and fell back upon the earth. This fallout, mixed with magma, mud, and steam, sent additional pyroclastic flows speeding down St. Helens' flanks. Later, slower flows came directly from the new north-facing crater and consisted of glowing pumice bombs and very hot pumiceous ash. Some of these hot flows covered ice or water which flashed to steam, creating craters up to 65 feet in diameter and sending ash as much as 6,500 feet into the air. Strong high-altitude wind carried much of this material east-northeasterly from the volcano at an average speed of about 60 miles per hour. By 9:45 it had reached Yakima, Washington, 90 miles away, and by 11:45 it was over Spokane, Washington. A total of 4 to 5 inches of ash fell on Yakima, and areas as far east as Spokane were plunged into darkness by noon, where visibility was reduced to 10 feet and 5 inches of ash fell. Continuing eastward, St. Helens ash fell in the western part of Yellowstone National Park by 10:15 p.m. and was seen on the ground in Denver, Colorado, the next day. In time, ashfall from this eruption was reported as far away as Minnesota and Oklahoma, and some of the ash drifted around the globe within about 2 weeks. During the 9 hours of vigorous eruptive activity, about 540 million tons of ash fell over an area of more than 22,000 square miles. The total volume of the ash before its compaction by rainfall was about 3 cubic miles. The volume of the uncompacted ash is equivalent to about 5 cubic miles of solid rock, or about 7% of the amount of material that slid off in the debris avalanche. By around 5:30 p.m. on May 18, the vertical ash column declined in stature, but less severe outbursts continued through the next several days. Ash properties. Generally, given that the way airborne ash is deposited after an eruption is strongly influenced by the meteorological conditions, a certain variation of the ash type will occur as a function of distance to the volcano or time elapsed from eruption. The ash from Mount St. Helens is no exception, and hence the ash properties have large variations. Chemical composition. The bulk chemical composition of the ash has been found to be approximately 65% silicon dioxide, 18% aluminium oxide, 5% ferric oxide, 4% each calcium oxide and sodium oxide, and 2% magnesium oxide. Trace chemicals were also detected, their concentrations varying as shown: 5–9% chlorine to 3% fluorine, and 9–3% sulfur. Index of refraction. The index of refraction, a number used in physics to describe how light propagates through a particular substance, is an important property of volcanic ash. This number is complex, having both real and imaginary parts, the real part indicating how light disperses, and the imaginary part indicating how light is absorbed by the substance. It is known that the silicate particles have a real index of refraction ranging between 15 and 16 for visible light. However, there is a spectrum of colors associated with samples of volcanic ash, from very light to dark gray. This makes for variations in the measured imaginary refractive index under visible light. In the case of Mount St. Helens, the ash settled in 3 main layers on the ground. The bottom layer was dark gray and was found to be abundant in older rocks and crystal fragments. The middle layer consisted of a mixture of glass shards and pumice. The top layer was ash consisting of very fine particles. For example, when comparing the imaginary part of the refractive index K of stratospheric ash from 93 and 112 Mi from the volcano, it has been discovered that they have similar values around 700 nm, while they differ significantly around 300 nm. Here, the 112 Mi sample was much more absorbent, the 93 Mi sample. Mudslides flow downstream. The hot, exploding material also broke apart and melted nearly all of the mountain's glaciers along with most of the overlying snow. As in many previous St. Helens eruptions, this created huge lahars and muddy floods that affected three of the four stream drainage systems on the mountain, and which started to move as early as 850 am. Lahars traveled as fast as 90 miles per hour while still high on the volcano, but progressively slowed to about 3 miles per hour on the flatter and wider parts of rivers. Mudflows from the southern and eastern flanks had the consistency of wet concrete as they raced down Muddy River, Pine Creek and Smith Creek to their confluence at the Louise River. Bridges were taken out at the mouth of Pine Creek and the head of Swift Reservoir, which rose 26 feet by noon to accommodate the nearly 18 million cubic yards of additional water, mud, and debris. Glacier and snowmelt mixed with tephra on the volcano's northeast slope to create much larger lahars. These mudflows traveled down the north and south forks of the Toutle River and joined at the confluence of the Toutle Forks and the Cowlitz River near Castle Rock, Washington, at 1:00 p.m., 90 minutes after the eruption. The first mudflow had moved 27 miles upstream, where observers at Weyerhaeuser's Camp Baker saw a 12-foot-high wall of muddy water and debris pass. Near the confluence of the Toutle's north and south forks at Silver Lake, a record flood stage of 235 feet was recorded. A large but slower-moving mudflow with a mortar-like consistency was mobilized in early afternoon at the head of the Toutle River North Fork. By 2:30 p.m., the massive mudflow had destroyed Camp Baker, and in the following hours, 7 bridges were carried away. Part of the flow backed up for 25 miles soon after entering the Cowlitz River, but most continued downstream. After traveling 17 miles further, an estimated 3,900,000 cubic yards of material were injected into the Columbia River, reducing the river's depth by 25 feet for a 4-mile stretch. The resulting 13-foot river depth temporarily closed the busy channel to ocean-going freighters, costing Portland, Oregon, an estimated $5 million. Ultimately, more than 65 million cubic yards of sediment were dumped along the lower Cowlitz and Columbia rivers. Aftermath. Direct results. The May 18, 1980 event was the most deadly and economically destructive volcanic eruption in the history of the contiguous United States. Approximately 57 people were killed directly from the blast and 200 houses, 47 bridges, 15 miles of railways and 185 miles of highway were destroyed. 2 people were killed indirectly in accidents that resulted from poor visibility, and 2 more suffered fatal heart attacks from shoveling ash. U.S. President Jimmy Carter surveyed the damage and said it looked more desolate than a moonscape. A film crew was dropped by helicopter on Mount St Helens on May 23 to document the destruction. However, their compasses spun in circles, and they quickly became lost. A second eruption occurred the next day, but the crew survived and were rescued 2 days after that. The eruption ejected more than 1 cubic mile of material. A quarter of that volume was fresh lava in the form of ash, humus, and volcanic bombs, while the rest was fragmented, older rock. The removal of the north side of the mountain reduced Mount St Helens' height by about 1,300 feet, and left a crater 1 to 2 miles wide and 2,100 feet deep, with its north end open in a huge breach. More than 4 billion board feet of timber was damaged or destroyed, mainly by the lateral blast. At least 25% of the destroyed timber was salvaged after September 1980. Downwind of the volcano, in areas of thick ash accumulation, many agricultural crops such as wheat, apples, potatoes, and alfalfa were destroyed. As many as 1,500 elk and 5,000 deer were killed, and an estimated 12 million Chinook and coho salmon fingerlings died when their hatcheries were destroyed. Another estimated 40,000 young salmon were lost when they swam. In total, Mount St Helens released 24 megatons of thermal energy, 7 of which were a direct result of the blast. This is equivalent to 1,600 times the size of the atomic bomb dropped on Hiroshima. Disputed death toll. There is a minor controversy in regard to the exact death toll. The figure most commonly cited is 57. However, there are 2 points of dispute. The first point regards 2 officially listed victims, Paul Hyatt and Dale Thayer. They were reported missing after the explosion. In the aftermath, investigators were able to locate individuals named Paul Hyatt and Dale Thayer who were alive and well. However, they were unable to determine who reported Hyatt missing, and the person who was listed as reporting Thayer missing claimed she was not the one who had done so. Since the investigators could not thus verify that they were the same Hyatt and Thayer who were reported missing, the names remain listed among the presumed dead. The second point regards 3 missing people who are not officially listed as victims: Robert Ruffle, Stephen Whitsett, and Mark Melanson. Cowlitz County Emergency Services Management lists them as possibly missing, not on the official list. According to Melanson's brother, in October 1983, Cowlitz County officials told his family that Melanson is believed a victim of the May 18, 1980 eruption, and that after years of searching, the family eventually decided he's buried in the ash. Taking these 2 points of dispute into consideration, the direct death toll could be as low as 55 or as high as 60. When combined with the 4 indirect victims mentioned earlier, those numbers range from 59 to 64. Ash damage and removal. The ashfall created some temporary major problems with transportation, sewage disposal, and water treatment systems. Visibility was greatly decreased during the ashfall, closing many highways and roads. Interstate 90 from Seattle to Spokane was closed for a week and a half. Air travel was disrupted for between a few days and 2 weeks, as several airports in eastern Washington shut down because of ash accumulation and poor visibility. Over 1,000 commercial flights were canceled following airport closures. Fine-grained, gritty ash caused substantial problems for internal combustion engines and other mechanical and electrical equipment. The ash contaminated oil systems and clogged air filters and scratched moving surfaces. Fine ash caused short circuits in electrical transformers, which in turn caused power blackouts. Removing and disposing of the ash was a monumental task for some eastern Washington communities. State and federal agencies estimated that over 2,400,000 cubic yards of ash, equivalent to about 900,000 tons in weight, were removed from highways and airports in Washington. The ash removal cost $22 million and took 10 weeks in Yakima. The need to remove ash quickly from transport routes and civil works dictated the selection of some disposal sites. Some cities used old quarries and existing sanitary landfills. Others created dump sites wherever expedient. To minimize wind reworking of ash dumps, the surfaces of some disposal sites were covered with topsoil and seeded with grass. In Portland, Oregon, the mayor eventually threatened businesses with fines if they failed to remove the ash from their parking lots. Cost. A refined estimate of $11 billion was determined in a study by the International Trade Commission at the request of the United States Congress. A supplemental appropriation of $951 million for disaster relief was voted by Congress, of which the largest share went to the Small Business Administration, U.S. Army Corps of Engineers, and the Federal Emergency Management Agency. There were also indirect and intangible costs of the eruption. Unemployment in the immediate region of Mount St Helens rose tenfold in the weeks immediately following the eruption, and then returned to near normal levels once timber salvaging and ash cleanup operations were underway. Only a small percentage of residents left the region because of lost jobs owing to the eruption. Several months after May 18, a few residents reported suffering stress and emotional problems, even though they had coped successfully during the crisis. Counties in the region requested funding for mental health programs to assist such people. Initial public reaction to the May 18 eruption dealt a nearly crippling blow to tourism, an important industry in Washington. Not only was tourism down in the Mount St Helens Gifford-Pinchot National Forest area, but conventions, meetings, and social gatherings also were canceled or postponed at cities and resorts elsewhere in Washington and neighboring Oregon not affected by the eruption. The adverse effect on tourism and conventioneering, however, proved only temporary. Mount St Helens, perhaps because of its reawakening, has regained its appeal for tourists. The United States Forest Service and the state of Washington opened visitor centers and provided access for people to view the volcano's devastation. Later eruptions. St. Helens produced an additional 5 explosive eruptions between May and October 1980. Through early 1990, at least 21 periods of eruptive activity had occurred. The volcano remains active, with smaller dome-building eruptions continuing into 2008. 1980–1991. An eruption occurred on May 25, 1980, at 2:30 am that sent an ash column 9 miles into the atmosphere. The eruption was preceded by a sudden increase in earthquake activity and occurred during a rainstorm. Erratic wind from the storm carried ash from the eruption to the south and west, lightly dusting large parts of western Washington and Oregon. Pyroclastic flows exited the northern breach and covered avalanche debris, lahars, and other pyroclastic flows deposited by the May 18 eruption. At 7:05 p.m. on June 12, a plume of ash billowed 25 miles above the volcano. At 9:09 p.m. a much stronger explosion sent an ash column about 10 miles skyward. This event caused the Portland area, previously spared by wind direction, to be thinly coated with ash in the middle of the annual Rose Festival. A dacite dome then oozed into existence on the crater floor, growing to a height of 200 feet and a width of 1,200 feet within a week. A series of large explosions on July 22 broke more than a month of relative quiet. The July eruptive episode was preceded by several days of measurable expansion of the summit area, heightened earthquake activity, and changed emission rates of sulfur dioxide and carbon dioxide. The first hit at 5:14 p.m. as an ash column shot 10 miles and was followed by a faster blast at 6:25 p.m. that pushed the ash column above its previous maximum height in just 75 minutes. The final explosion started at 7:01 p.m. and continued for over 2 hours. When the relatively small amount of ash settled over eastern Washington, the dome built in June was gone. Seismic activity and gas emissions steadily increased in early August, and on August 7 at 4:26 p.m., an ash cloud slowly expanded 8 miles into the sky. Small pyroclastic flows came through the northern breach and a weaker outpouring of ash rose from the crater. This continued until 10:32 p.m. when a second large blast sent ash high into the air, proceeding due north. A second dacite dome filled this vent a few days later. 2 months of repose were ended by an eruption lasting from October 16 to 18. This event obliterated the second dome, sent ash 10 miles in the air, and created small, red-hot pyroclastic flows. A third dome began to form within 30 minutes after the final explosion on October 18, and within a few days, it was about 900 feet wide and 130 feet high. In spite of the dome growth next to it, A new glacier formed rapidly inside the crater. All of the post-1980 eruptions were quiet dome-building events, beginning with the December 27, 1980 to January 3, 1981 episode. By 1987, the third dome had grown to be more than 3,000 feet wide and 800 feet high. Further eruptions occurred over a few months between 1989 and 1991. 2004–2008. The 2004–2008 volcanic activity of Mount St Helens has been documented as a continuous eruption with a gradual extrusion of magma at the Mount St Helens volcano. Starting in October 2004, there was a gradual building of a new lava dome. The new dome did not rise above the crater created by the 1980 eruption. This activity lasted until January 2008. Further reading. Eruption of Mount St Helens. National Geographic. Vol 159 No. 1 January 1981 pp. 365 ISIN 27 9358 ACOC 643,483,454. Findlay, Row Mount St Helens Aftermath. National Geographic. Vol 16006 pp. 713–733. ISIN 27 9358 ACOC 643,483,454.